Good afternoon or good morning to everyone. Welcome to a new edition of the Smart Talks by MESPAC. This time it is a pleasure for us to present this webinar by the hand of Watttron, one of our stellar partners. I am Monica Cuatacasas, Communication Manager at MESPAC. Nice to greet you. And today we are delighted to have you join us for this session entitled Smart Digital Sealing for Sustainable Packaging, where we will know more in detail about this innovative solution for sealing monomaterial films. This webinar is scheduled to last approximately in 45 minutes and will be presented by our expert Markus Stein, CEO at Watttron, Stephen Storm, Product Manager at Watttron, and Guillaume Juret, Innovation Manager at MESPAC. Following the presentation, we will allocate around 10 minutes for questions and answers. So please feel free to submit your question during the session through the question and answer section below. The session will be recorded and shared with those who have registered later. Now, let me introduce the speakers. The first one is Markus Stein, CEO of Watttron and key innovator behind the company's groundbreaking digital heating technology, has been driving force since the company's inception. As a founder, Marcus' vision and leadership have propelled Watttron to the forefront of intelligent heating solutions. His deep expertise and commitment to innovation ensure that Watttron remains a pioneer in the industry. He is continually pushing the boundaries of what is possible with digital heating technology. Good morning, Marcos. Glad you
Yeah,
to hear you with us today.
yeah.
How
Thanks.
are
Good
you?
morning. Good morning and good afternoon to everyone.
Okay, perfect. So I would like to introduce you also Stephen Sturm, Product Manager for Zero to Seal at Watttron. He has been with the company for over 3 years, and during this time, he has been instrumental in advising his sealing applications technology. Stefan's expensive expertise and dedication ensure that Watttron solutions are continually refined and optimized. He works hand in hand with the partners and customers to test and implement innovative sealing technologies, driving forward our mission for excellence. Hi, Stephen. How are you today? You are mute, Stephen.
Yeah, hello. Also from my side, appreciate to be here to have this opportunity to speak about our technique.
Fantastic. Now, I'd like to introduce you Guillaume Juret, the Innovation Manager at MESPA. With more than 9 years in MESPA, Guillaume is a person who leads the innovation team, one of the fundamental pillars in the company. Senior electronic automation engineer with extensive experience in the packaging world, Guillaume works closely with partners and customers, testing with them the new solutions in MESPAC Innovation Center. Good morning, Guillaume. How are things are going today?
Hey, Monica. Good morning, good afternoon. All good here. Like always, a pleasure spending some quality time with all of you guys.
Fine, great. Thank you, three, for your contributions to this session. With nothing further to add, let's proceed with the presentation. Okay. Today, we are going to cover different topics about smart sealing for sustainable packaging. But first, let me introduce you a quick MESPAC overview, just for you to know who we are. MESPAC, headquartered in Barcelona, is a global leader in flexible packaging and equipment for consumer packaged goods. We are known for our innovation in creating sustainable packaging solutions. MESPAC has been part of Duravan since 2015, a leading player in the world of industrial equipment headquartered in Illinois. Duravan is a global engineered equipment company with manufacturing, sales, and service facilities throughout North America, Europe, and Asia. Duravan offers immediate and lifelong aftermarket support across sectors serving food processing, packaging, and material handling industries worldwide through its diverse portfolio of operating companies and brands that you can see here in this slide. About MESPAC, MESPAC has been established in 1994 as an horizontal form, fill, and seal manufacturer and has evolved into a global one-stop shop with extensive services. With sales team in over 90 countries and regional service centers ensuring prompt access to parts, we boast the industry's largest portfolio. With 380 employees across 17,070 square meters of facilities, our production centers are in Spain, the US, and India. MESPAC provides solutions for various industries, including food, beverage, pet food, pharmaceuticals, personal care, and home care. Additionally, we serve industries such as law and garden, agriculture, tobacco, automotive, and more. And at MESPAC, our talent engineering team designs customized integrated solutions for primary, secondary packaging, and end-of-line processes. With our extensive portfolio that you can see here, we offer high precision, efficient, and versatile horizontal form, fill, and seal machines for flexible packaging, including machinery for pre-made pouches and a wide range of vertical form, fill, and seal equipment. Additionally, we provide hydroforma machines for water-soluble pods and end-of-line equipment to fit your secondary packaging needs, offering turnkey solutions if it's needed. So this marks the beginning of our introduction to MESPAC, providing you the opportunity to be familiarize yourself with who we are. And now, Marcus and Stephen, I'll pass you the floor to you. Thank you. No, sorry. I'll pass the floor to Guillem Lloret.
No problem. Okay, so let's start with sustainability. What you can read here is our enabling sustainable packaging for the green world. This is really rooted in our DNA because we believe that we just have one planet, and it's all of our duties to keep it as best as possible, because otherwise we have a place to live. So with MESPAC, we put a lot of effort and a lot of energy on developing new things to help our customers embrace this journey with us, and that every day packaging will be greener. So to do this and conceptualize it, we have created the 6R strategies. All of you that have heard about these sustainability topics, you will know that it's all about R's, so everyone is making their own R's. So we have divided them in 3 different buckets. The first one is for materials. So what can we do on materials to make them better, either directly or with our partners. The second one is something that's related to equipment, and the last one is to packaging. On the material side, we have 3. It's reducing, basically using less, replacing, changing materials which are not sustainable for those who are sustainable, removing, which would be packaging that disappears, re-engineering, so adapt our machines to be able to work with the materials created on the previous 3 Rs, retrofitting, that all this technology will be able to be placed in existing machines, and last but not least, reusing, which basically it's following the path of eliminating the single-use products. I will go a little bit more in depth in each one of these Rs, just for you to get a flavor of what I'm talking about. So the first one is reducing. Plastic, so flexible packaging per se, it's more sustainable compared to rigid plastic because we use much less plastic. You have an example here where you can count more or less that we use 70% less of plastic, but this also has other benefits implied, which basically means that you need less amount of material to move bigger amounts of product. So also in carbon footprint, in transport costs and so on, this gets a plus benefit. But we also have some technologies that we can apply to our machines to reduce even more the amount of plastic that we will use. We focus on 2 areas basically. The first one is reducing the headspace. The headspace is that space that you would have from the top of the liquid up to the top of the pouch. You can see it on the figure on the bottom side. The one on the left would have a lot of headspace. The one on the right has an appropriate amount of headspace. We have one series of machine, which is the HF that fits through the spout, that helps a lot in these regards. But we also have other models with continuous motion filling, like the carousel models, that also help in this. The second technology that we have are laser cutting systems. This is for all those customers who want to make round shapes or certain shapes in their pouches. This technology can help on reducing a lot of the costs because we save the amount of film required to make these shapes. The second R, it's replacing. So we are in a position today, or a little bit a couple of years before today, where we had plenty of materials, basically PET materials or nylons, that they were performing really good. We had, let's say, answers for all the needs with all the types of barriers, with all the type of products, with all the sizes and shapes that you would think of. But they had a very big downside that those materials were done merging different types of polymers that then they cannot be, let's say, separated from one another. The new stream of materials, the sustainable ones that has come now, they are recyclable, so that's a very good thing. They comply with the regulations, but they are a little bit more difficult to work with in our machines. We have to face basically two different issues that are, let's say, the most relevant. The first one is that they tend to be a little bit stretchy, so it's more difficult to control the accuracy of the machine. And the second one is that heat affects them much more. So the sealing windows that we can work with, they are much more narrow. That's one of the whys we decided to make this partnership with Watttron, and we'll explain you how they can do that better than me later. On the streams of materials that we see today, we are focusing now on recyclable ready, which would be materials, what they call the monos. Basically, the whole structure of the film is made with different versions of the same polymer, either polyethylene or polypropylene. There is a second stream of materials that it's coming today that we are seeing every time more and more, which is basically paper, and also adding PCR, so film that has already been processed and recycled on the film structures. And the one that we see more in the future that it's not yet here, which would be the biodegradable or compostable materials like PHA or PHB. This slide just shows some examples of what we have been working in this regards of replacing. Basically, the use of paper. This is very extensive on our customers that pack either powder or that they pack solids. We've been working a lot on adapting technology for controlling these bigger differences, and you will see why with Watttron we got a very good solution on that. And also, we've been working with the biodegradable plastic films. This is a project that is ongoing. We don't have a solution yet, but it's worth to mention because we believe it's the next step. Sorry, it went too far. We also have the reusing of the pouches itself, so that instead of using it once, that you can use it more times. There are different types of packaging that you can find in the market to do this. One example that we put here, it's a refill pouch made of paper that could be used, for example, for cacao. You can also see other examples on the market like spouted pouches that can be used to refill a shower gel, can be used for hand soap, this kind of stuff. But all these materials, as I mentioned, they are a little bit trickier to work with. So we need to re-engineer our machines, so make them better, make them more precise, to be able to work with them and keep the same performances that we are having today. We have developed a lot of different technologies. Today we will talk about, let's say, that maybe one of the most modern or future-proof that you can see. But basically, when we do that, we face different, let's say, targets to do it. Basically, that they do the job that it's required, but also that they will use less energy and that they will bring the quick changeover embedded on. But all these technologies, we keep in mind that our customers, they already have machines, and we cannot go and say, look, you have to throw your machine and buy a new one, because we know that's completely impossible. So everything that we think of, we always think that there are machines in the market and that that has to be able to be implemented there. This is not 100% all the times, but we try that at least 99, it will happen. Okay. Here we put just some examples. The first one is the smart digital ceiling from Watttron that soon they will explain how it is. And there are other examples like the bottom jaw cooling or perforators with larger stroke. That those are technologies that we have been developing. This is just written as an example. And before passing it to the guys from Watttron, I wanted just to give 5 quick bullet points about why. So what we were looking when we decided to make this partnership. The first one is to be much more precise on how we control temperature. As I mentioned, the new materials, they are much more tricky to work with. So that was a must for us. The second one, it's their process is fast, so they can heat up and cool down in a very fast way. This can bring us a lot of benefits, especially when we start and stop the machine. We wanted the system that it's energy efficient. So today energy costs are not super high, but in the future we foresee that they can be. So we think that it's a good thing that we will have for the future. We wanted it to be integrated with Athena. Athena is our software platform, and whatever we would do, we wanted to have a seamless integration with it, and with them we are developing that, and we will have this. And also we wanted the system that could provide us with data to do things in the future, and they are kind of in their system. They can check all these 5 boxes properly. Okay. So I pass it to Marcus.
Yeah, many thanks for your explanation. I think, yeah, first of all, thanks, Guillaume, for doing your presentation. And I think I can now only prove your points. You already, I think, raised the main points, what is about our technology. And so it's a great pleasure for me and also for my colleague, Steffen, I think, to talk to you about the great cooperation between MESPAC and us, and to give you a little bit more insights about our digital heating systems. So for me, the goal is the following. I think I want to present you first to demonstrate you why is the clear benefits regarding increasing the productivity and also the efficiency of your production lines or your packaging lines today. Secondly, I think I want to explain you the reason why digital heating is for us really the enabling technology when it comes about monomaterials and monomaterial processing. And the third one, but this is, I think, already shown by Guillaume and mentioned, we are not only looking on new machines. The system has a great advantage that it can be very easily integrated into existing machines and implemented as a retrofit in a machine. But let me start with a short introduction about Watttron. So because Watttron is maybe not that known at the moment like MESPAC. Watttron is a spin-off of the University of Dresden. I can say that Dresden is really a hotspot of research and development in Germany. We have very great, very big university here, but also very known external research organizations like Fraunhofer. Another great thing on Dresden, and I think that's where I can do some marketing for here, also have a look on Dresden, is that we have a dedicated institute for packaging technology and processes. And here I met my 2 colleagues or my 2 co-founders, and we together in 2016 spinned off the company from the university. Today, I can say that Watttron is a team of more than 80 talented and highly skilled persons. So the team is grown a lot over the last years. But not only here in Dresden, in this area, we have a growing number of international working colleagues. Today, we have already a person in Milano in Italy. We have someone in the US, or 2 persons already in the US in office. And very fresh, we started an office and work with a person in Tokyo, in Japan. That means for most of the people in the audience, I think we can provide already a local sales support, and of course much more than also in cooperation with the machine suppliers. About our customers, I can say that when we started, we mainly worked with the leading CPGs like Procter & Gamble or Reckitt Benckiser, many others that I'm not allowed to mention, unfortunately, but all asked us to support their sustainability strategies by typically retrofitting of their machines. The machine builders itself, at the beginning of Watttron, they were a little bit more conservative, but we are happy about the fast-growing number of innovative OEMs, like you can see with Messpack in particular, who are now cooperating and offering the digital sealing systems, mostly under the slogan "Powered by Watttron" to their customers. But let me start and let me come back to the technology, and let me start with a short summary of the aspects or the topics of our existing customers, typically saying which are the biggest challenges, even when you process normal materials, but much more, and in particular, when it comes to monomaterials. There is the first one, and I think that's really the biggest or the most relevant reason why recyclable materials, monomaterials, are still used so rarely, and more CPGs, and I think you can see this in the media more and more CPGs are reporting that they are much behind their own goals they set for the use of recyclable packages, producing recyclable packages. And this is the lack of productivity compared to standard laminates. This lack of productivity that is mainly caused by a forced decrease of the machine speed and an increase of losses during the production, for example, during a restart of a machine. We saw a real case at a customer who had to lose 25 pouches when he restarted the machine after a machine stop. After the retrofit, for example, now he can run the machine and when he restarts, he only loses 4 pouches, which is a relevant factor also for him when it comes to a decision, I want to change to monomaterial or not. The second aspect is the much higher risk of quality issues with pouches or pillow bags made with monomaterials. It's measurable, so it's clearly measurable, typical as an increase of packages with leakages, mostly in the triple point, that's the critical area, or you have clear burning marks or strained areas in the heated area. The third thing is more a qualitative thing, so you can also have optical disadvantages or optical impacts, typically caused by the reduced tolerance of such monomaterials against a thermal impact. The result is mostly a deformed pouch or a shrinked seam. So the question is now the following, of course, why digital heating is solving these quality issues and why equipped machines in the field already show a clear improvement of performance and an increased number of qualitative packages. Let's say, what is the magic? The magic is the local defined heating. Instead of a large heating source, like you would have with a heat cartridge in a sealing jar, this shows a very slow running controlling performance with many delays in the reaction of the heating system, which then cause temperature variations. We created a heating system. We call this digital heating, based on very small and individual controllable heating pixels. The pixels are very small. They are only about 5 × 5 millimeters. And this is the very specific, each pixel, and I really say each pixel, so each 5 millimeters heat area is heated and controlled separately from each other. And these pixels are heating directly on the surface and are only covered with a small metal layer, which then at the end is the sealing profile. Such a pixel, for the engineers here in this audience, such a pixel can heat up with up to 70 watts per square centimeter, so they are very powerful. In comparison, a normal heating jar has only 5 to 10 watts per square centimeter. So this gives a very high dynamic of control, fast heat up, but in combination with this very low thermal mass, a very defined and local and precise heating. Beside this, the dynamic of the control of the temperature, the local definition is the key advantage when it comes to monomaterials. The question is why? Because the pixels can control local variations. Yeah, everyone knows when you have a pillow bag, you have a thin area with a layer step, or you have a side gusset or a bottom gusset with a layer step, and the pixels can now control the local variation between the area with 4 layers and the areas with 2 layers, where today, if you have a standard heating system, there is not really a way how to control it locally. And of course, the very big difference when you have a bigger sealing jar or larger sealing jar and you want to seal a smaller pouch, this variation, I think for everyone is clear. The pixels which are not in contact have to heat much less than the pixels which are in contact. In contact. At the end of the presentation, we also show you a short video, which also a little bit summarizes these benefits. But let me take over to Steffen, who wants to give you, or who will give you much more information about the applications, and especially here for the HFFS machines. So Steffen, thanks for.
Thank you very much. Thank you, Marcus. So Marcus introduced to you what is behind, or more or less inside the sealing jar, but what does it mean regarding a whole packaging machine? For example, let's have a look to a Messpack HFFS sealing machine. So we have and we will and we can provide different types, different shapes of sealing jars, all with the same technique, the pixel-wise heating in a really small resolution of heating pixels. For example, we have these vertical sealers. Marcus mentioned that, and also Guillaume, that you can there adjust pixel-wise, for example, and the most important area there, the triple point, where you also can adjust for special monomaterials very precise the temperature, and then you are able to achieve this really narrow sealing window. Then we have two different types of bottom sealing, the straight one and the format sealing jar. This will be provided with different format plates, different shapes, and so on. So then regarding just according to the needs from the customers and so on. And we have these top seal sealing jars. The flat one, which is more or less the same like the vertical, but in another design outside. And we have these top spout sealing jars, which can be as a one sealing jar or a single head sealing jar, depending on the kind of machine. And that the huge advantage is that you can adjust really high difference between the film and the film spout area to make a setup to seal all these special and new kind of recyclable monomaterials, which allows you to have a stable process with less NEO parts and so on. And for that, it means we can equip a whole machine with the digital sealing. What else? We have tools for the HFFS circular as well. That means we call it internally the high speed or higher speed machines. We can provide tools for VFFS machines, which has some more differences, advantages regarding the layer jump to the thin sealing. This is also all regarding the flexible packaging, and besides the flexible packaging, we can also provide some sealing tools for the rigid packaging for FFS cups and FFS trays. By the way, besides our sealing tools, we also provide heating elements to produce these trays, cups as well. So what does it mean? Guillaume talked a little bit about it. So the main USPs on our side are processing the monomaterial. We talked about that the last 30 minutes. Energy saving, I will show you some slides later on. The fast ramp up and cool down, it's really a tricky thing because we are able to run the sealing jars with 10 to 20 Kelvin per second, or degree C. So that means you will be ready to seal within seconds. And also the cool down will be much faster than if you have a full metal sealing jar with a heat cartridge. Marcus said the machine integration is really easy. It is for new machines, of course, and also for retrofit. We have done a lot of retrofit installations on old machines. Some of them have been in the age of 30 or 40 years, so it is no problem to integrate them into the machine. Also, if there are machines which are a little bit tricky, we have good engineers to solve these problems as well. And by the way, we can also increase the productivity because of the lower amount of not good sealed products and reducing the start and stop pouches. Here a slide on the right side, you see our user interface. I mean, we can talk about that later on, but just to show you how does it looks like, we can provide such temperature profiles to achieve a better sealing on the triple point, and we can also switch off sealing jars in case of having smaller pouches but a large sealing jar and so on. Coming to the saving potential. This is just an example, and as you can see there, and we have seen this also on retrofit machines and installations in the last month, that by using the Watttron Serra to seal technique, our customers have been able to increase their outcome. And just to give you an idea, what does it means in cash? This is just an example. Besides the saving potential money-wise, you can also save a lot of money regarding the energy. I mean, this is just an example with 8,000 euros, but just keep in mind, it means not only 8,000 euros in cash, that also means you have less energy, heat, temperature in the machine. That means if you open the machine and the operators need to have need to do some cleaning stuff and so on, there's you can touch the sealing jar while heating. So this is really less thermal impact in the machine. Okay, then Marcus, I guess, or I can start the video. So it should work.
Yeah, I think we see again a short summary of this, what Steffen and Guillaume and I measured. We have the sealing jar with the heating pixels behind such a sealing profile, and the sealing profile can be the standard like you have today. But very important to understand is that the sealing jars works quite different than a standard system. It's heating in the moment when you have a heat consumption. And if there is no heat consumption, for example, you stop the machine, it stops heating, but keep the temperature constant. And this is the quite difference, heating on demand. Yeah, and then you can have this local advantage. I think we talked a lot. Pixels who are in this 4-layer area, they see a higher heat consumption by this more material. And this more heat consumption is at the end controlled by a higher heat production. And this is exactly the key to have a qualitative seal on such a layer step or a variation. And this variation you not only have in terms of a pouch with a layer step, you have this variation especially or particular when it comes about spout sealing. A spout injection molded, let's say a very thick part compared to the film needs a different heating than the film. By the way, for this application in the field, we won the World Packaging Award together with Watttron, where we first time enabled a mono PP pouch on an FFS machine, made on an FFS machine, horizontal form fill sealing machine. But the principle is still the same, what we saw on the sealing jar. The local variation, in this case, the pixels in the spout area, they produce more heat than in the 2-layer area, so it prevents to have an overheating, melting, or a shrinkage of the shoulder area, but still you have the control that you get a good seal, a tight seal in the spout area. And another thing we are working on, we call this the inline quality check. We can use the information from the pixels, how much energy they use to, let's say, look in the sealing process, to have an idea what happened during the sealing, because there's a difference if you seal the spout area or the film area, or you seal an area where you have a contamination by, for example, a product. This causes a local variation. And this variation, we are working on algorithm to control exactly this. Yeah. And here you can see such a retrofit of a pouch machine, and this is the pouch lab, so it's available to run tests. We have the design is like this, that it fits into packaging, into mass pack machines. This is, let's say, solved. The mechanical implementation is solved. The software implementation is solved. So I would say ready for you to think about it and to move together with us the next step to sustainable packages. So I take over to Guillaume, right, for the last.
Yep. So the last part, it's as you have seen in the video, we have a machine in our innovation center that it's fully dedicated to trial new materials, new technologies. This machine has many capabilities, like it's written on the left, but from, I say, after summer, we'll have the capabilities for vertical sealing as well as bottom sealing with the Watttron technology that will be embedded on our report system. So you can feel free to contact us, and we can schedule a trial to see if that would work with the films that you would require. Just to wrap it up, about the trials that we do there, we think it's a very good thing for our customers and partners. Basically, we do everything on a controlled environment in a very scientific way, so it's very repeatable over time. All the data can be compared to previously acquired data and take decisions. The results are accurate, and we get a lot of know-how on what needs to be installed on machines. We avoid downtime. These our customers like it a lot because they have a machine on their disposal with one senior technician, and they do not have to stop their production line, so they are not losing money at the end of the day. And we are getting, as I mentioned, a big database of knowledge, so it takes few time for us to evaluate if a film is working or not, the same as with technology. We think that with this partnership, we can go one step further on working more efficiently, maybe even in more complicated films that today we could not work with, and to have an overall machine that will be a better output for the future. So, yeah, as I mentioned, we've made plenty of tests, and with that, we will wrap it up. Those three sentences, I think they let's say synthesize very well what we are trying to do. As we mentioned, challenges are not something from the future. It's something that it's happening today. Our customers are embracing it today, as Marcus mentioned, not as fast as they would like to. So we are trying to help them on making it in a faster pace. We want to adapt our machines to work with those technologies. We are doing it already. We have plenty of customers that are already working with sustainable materials with success. That's the important thing, and not losing productivity. And at the end of the day, all we try to do is try to help our customers, work with them along this path, and be by their side for whatever they need. And that's all from my side. Monica, you want to take over?
Yes. Well, Thank you all three for your participation. This trend topic, smart digital sealing for sustainable packaging, has been very, very interesting, providing value insights into the precision and efficiency of sealing product pouches with monomaterial films. With such an engaged audience, let's move to the round of questions and answers that we have some of them ready to be answered. So first question here is how extensive is the effort required for a retrofit? I don't know who wants to answer.
Steffen, do you want to?
Yeah, thanks. It depends, but in the most ways there is no big deal to do this because we will do this together with Messpack, and yeah, that is it takes more or less 1 or 2 days to install our sealing jaws into an existing machine, and then the production can start again. So, yeah.
Okay. Thank you, Stefan. Another attendee asks, are there already reference partners where the systems are successfully in use?
So I can say, as mentioned, yes, there are many, not only in Europe, I can say. So we already have installations in Brazil, in America, in Japan. So I think we already helping customers globally, and yeah, and for example, and especially we already, let's say, have this cooperation working that we can provide this solution to everyone. That's, I think that's the important message, that this is the great outcome of this cooperation, that we can really provide for everyone at Messpack customer.
Okay, thank you, Marcus. We have another question. What is the lifespan of the technology?
We expect 3 to 5 years of lifetime, and but we have also systems in the market which are running since 7 years. So
okay.
It also depends. It also depends, of course, on the customer and how they work with our system. But I think we are in the same shape like standard systems. So we don't expect differences. No.
Okay, thank you. We have more questions. What application and potential do you see for this technology?
Maybe it's more for Messpack. So I don't. But
yeah, I mean there are many different applications where we see potential for this. As I mentioned, vertical and bottom seal, it's the first to go for us, because we've heard from our customers that they are rejecting plenty of pouches when they restart their machines, as Marcus mentioned. So that's the first thing that we want to tackle. Then moving on more in the future, spout sealing and even zipper sealing and so on. So we have defined a good roadmap with Watttron, and I think that will work on that to tackle all those needs.
Yeah, I agree.
Okay, thank you. How can we test Watttron technology on Messpack machines?
Yes, as I mentioned before, we will have vertical seal units and bottom seal units on our innovation center. So we will add on our report an option to test that technology, and yeah, it will be as easy as it is to do all the other trials. You just contact us, we define a day, and we do the trial.
Okay, thank you, Guillem. And another question that I think it's for you is, can we retrofit Watttron technology to any Messpack machine?
Yeah, we can do that. Then it's a matter of how much we want to integrate it in the control system of the machine. So with Watttron, we can do it fully integrated or not so fully integrated. So depending on the machine model and basically how old the control system is, we can go deeper or not so deep. But I think that we can find solutions for a new machine.
Thank you. More questions? We have an interactive public. Is there a need to preheat the weld spout to achieve a proper welding?
Well, it depends on the kind of spout. So we have done retrofits on existing machines without any preheating of the spouts. So it worked pretty well. But imagine that you have a really sensitive film and let's say a huge spout. It might be necessary to have a kind of preheating in different way. So we also investigate in this direction. So we are testing and checking things to also reduce the amount of energy, the amount of temperature for the preheating. We have some smart solutions on the table, let's say it like this. But we will see what's going on in the future.
Okay. Another attendee. I understand you monitor individual pixel power consumption. Can you talk about reliability when you are dependent on many individual pixels rather than the single large distributed thermal mass of a conventional sealer?
So when I understand correctly, the question is about the difference, because we have this very small pixel, and indeed, so we get data or we get feedback of each pixel, how many energy he used for a single sealing step, and this we are going to use as to analyze the sealing process, and because it's such a small pixel, we can, let's say, look very deep into the sealing process. Our first application in this field is not in the pouch area, it's in the area of sealing cups with a sealing head. When it comes, for example, on a lid sealing, we have there one application already running in the cosmetic area, where we detect for the customer if the lid is in the right position. Is there, for example, the lid is not in the center position, we can see directly by the sealing and the reaction of the pixels that there's a variation, and we can say to the machine, here is a bit not in the right position, please reject. And from this principle, from this first application, we are now working with customers, with MESPAC, to expand this also to other applications. I hope this answers the question.
Okay. More questions. So the pixels can get damaged individually and replace it individually, or you would have to change the jaws completely?
Well, in this case, it's necessary to replace the whole jaw and send it back to us. We can do a replacement then, and then usually our customers does have one or two additional sealers in the factories that they are able to run again very soon.
Okay, thanks. More questions. How does this work on MESPAC's continuous motion machines, especially carousels?
I understand we are talking about the HDM platform. So basically in there, what we have are, on the continuous motion side, we have top seals. So the top seal, it would be the standard tooling that they have, and they have shown on Stephen has shown on the pictures. So basically, the movement in that point, it's not done by the jaw, it's done by an external device. So it would be as easy as just changing one for the other.
Okay, thanks, Guillem. Another question. I would like to ask about the maintenance system of this system. Since it has temperature pixels, in case a pixel fails, the pixel can be changed or the set of pixels must be changed, which is the main point to take into account for maintenance.
Yeah, it's more or less the same question than before. So
okay. Perfect. So it has been answered already. Okay, another question. How sensible are those ceiling clamps to misalignment? Can it be fixed if any damage caused by misalignment take place?
It's a matter of the amount of misalignment and let's call it destroying something. We have during the development of our products, we have done a lot of tests with loading tests and so on, and we checked also what is the maximum pressure what the ceiling jaws can keep. And most of the time we got the information that the machine stops and says there's something wrong with the system, but our ceiling jaws have been working the whole time, so this is so no worries about that.
I think what covers this general question more generally is that we have customers where we retrofitted of this factory the first machine with a small production capacity, and we go through this factory up to now. We are covering, or the customer decided to use Watttron for more than 50 or 70% of their production capacities, and these are large CPGs, large food producer. I think this answer is more a general one, but I think we can show this answer gives you an idea that we are able to convince these customers that we have a robust and a reliable system, and we can work more than bring not only innovation, we bring also a sustainable solution. Otherwise, I think customers would not decide to expand to the whole production facility.
Okay. Very active audience we have in this interesting topic. Can you run the new materials as well as the existing laminated on these digital tools?
Of course. And this is one really big advantage, that you just change the temperature, or as we call it, the temperature profile, and then you can run aluminum laminate, and a few minutes later on you can run monomaterials. So no problem.
Okay. I understand that the ceiling system comes with the software to control each pixel and monitor the behavior. This is part of the operating system embedded in the MESPAC machine that it is on the panel of the machine, or it must be installed in architecture apart.
So the system will be 100% integrated on Athena. So let's say through the control panel of the machine, you will be able to adjust all these pixel temperatures and see the power they are consuming and so on. So yeah, it's 100% integrated on the machine.
Okay, thank you, Guillem. More questions. What temperature difference can be set or is feasible between two pixels placed next to each other?
The setting, there's no border, so you can set 100-degree and the next one can be 130-degree. But as we explained, there is a thin layer of metal over the heating pixels to protect them. And then a little of the thermal energy goes to the right and to the left. Let's say it like this. What we see regarding the triple point, in the most ways, you just need a few Kelvin or degree Celsius for the triple point more, so +3 or +4, and this is achievable. So in case of having much more, for example, on a spout tool, it might be necessary that you have a temperature gap of 20, 30, 40 Kelvin or degrees Celsius. We can equip the tool with a special cooling unit to cool down the film area compared to the film spout area. So.
Okay, thank you, Stefan. Another question is, what is the maximum admissible press?
We It depends on the sealing system. For example, for a VFFS machine, we have more stiff tools because it's necessary based on the process. On the HFFS, it's a little bit less. There we need more the dynamic and so on. We expect and we design our sealing jaws in between 5 to 15 megapascal. And then, I mean, it's depending on the surface and the pressure.
Okay. How flexible is this software to take data and take it to platforms like Azure or AWS?
I can say there are tools to manage this. This is not a big deal. But typically the question is what we are discussing then with the CPGs are they allowed to put the machine on the internet? That's a topic we cannot solve. That must be done by the CPGs. What we can provide is from our perspective, safe and secure channel, but it must be open. Yeah.
Okay. So the time is running. There are more questions, but we cannot attend all the questions. We are sorry, but we can send your questions by email and we will answer you for sure. So thank you, Marcus, Stefan, and Guillem. Thank you to all of you for trust and for being with us today. We invite you to contact MESPAC as well as Watttron for any questions. We encourage you to contact by sending an email to marketing@mespac.com. If there is any question for Watttron, you have also here the info@watttron.com. And looking forward to seeing you soon at our next Smart Talks. Have a great afternoon and best regards. Thank you very much.
Thank you very much.